Hi class! I know that you missed me. So for this week's discussion, I'll be presenting to you how to find the areas under the normal curve. Because of the emerging crisis we are facing right now, I decided to make this video for you to understand our lesson for this week. I would be very open to answer your questions through our Binield official email account. So if you have questions, just don't hesitate to send them to mrvic.depedro@binield.edu.ph. Now, we have to go to our PowerPoint presentation. So, recall that in normal distribution, we have these areas under the normal curve. So, notice that from the mean to the first standard deviation, the area is 34.1, which is the same area from 0 to the first standard deviation to the left. And then from the first standard deviation to the second, you have 13.6, 2.15 from the second to the third. Because of the property of symmetry, we'll also see the same areas on the left side of the distribution or on the lower distribution. So, part of our lesson is finding areas under the normal curve, which you may also apply in real life problems. So for you to understand finding the areas under the normal curve, let us proceed to discussing examples. So the first one is you have to find the area from z is 0 to z is 1.35. In answering questions like this, you will need a table of values. So if you have your book, Elementary Statistics, you can find it on page 74 of your book. So, ayan, this one. So, you may use this table. I will also send a copy of, ayan, the normal distribution. Maybe a screenshot of this so that you can, ayan, still find the area even though you don't have your book. Ayan, so you will need this. Do you have to memorize all of this? No. But you have to get a copy of this table for you to get the areas under the normal curve. Now, let's go back to the example. Find the area from z0 to z is 1.35. You have to follow two steps in answering this one. The first one is you shade the required region. So where is it in the normal distribution? So from 0, so that is already the midpoint. So the line that you see at the middle is 0. Where is 1.35? Is it on the upper distribution or left distribution? Upper. So maybe in between 1 and 2. It's only a sketch, so it doesn't need to be perfect. So we need this area from 0 to 1.35. How will we find the area from 0 to 1.35? You know what? This table gives you the area from, so let's use this whiteboard. Ayan, this table gives you the area from the mean 0 to any z that you want. So whether positive or negative. Ayan. So we're very lucky because we can utilize the table and find the area under the normal curve. So again, if we go back to this example, our z is from 0. And this is what the table gives us from 0 to 1.35. So what we have to do, we look for 1.35. So you go to the leftmost or left side of the table and look for 1.3. And miss, we are looking for 1.35, not for 1.3. Then that means you still have to add 0.05. So you have to look at the uppermost row. So what you have to do then, get the intersection just like in multiplication table. So 1.3 and 5. 0.05 rather. So what's the intersection? That is 0.4115. So that is the second step. You use the table to find the area. So, and you will find 0.4115. So the probability is 41.15. So notice that we just multiply our area by 100 and affix the percent sign. If you have a problem like this may also be restated as find the probability that z is greater than or equal to 0, but less than or equal to 1.35. In symbol, you may write that as the probability of z or getting z in between 0 and 1.35. So you will use less than or equal to symbols. What if you have to find the area from 0 to negative 1.35? Or you will get the same answer. So remember the property of symmetry. The area to the right side or to the upper distribution is the same area that you will get on the lower distribution. So this is pointed out here. The table on page 74 gives only the area from 0 to positive z because the area from z 0 to 1 is equal to the area from 0 to negative 1 because of symmetry. Class, this is actually number 1 of your worksheet 6D. So this may be copied for your reference or for as your example because later you will be doing the rest. So I'll be giving you more examples. So let's take example number 2. Find the probability that z is in between negative 2 and 2.5. So what's the first step again? You have to shade the required region. So where is negative 2.0? Upper or lower distribution? Lower. How about 2.5? Upper. So what do you notice about the area of interest? So we have to what? Find the area from 0 to 2. Find the area from 0 to 2 and find the area from 0 to 2.5. And what we have to do with the areas? Add. So we find first the area from 0 to 2. Again, we will need the table from 0 to 2. Why 2? It's negative, miss, because from 0 to 2 and from 0 to negative 2 will give you the same area. So we need to find 2.0. Since the second digit is 0 also, so you will have 0, 0. And that is 0.4772. Okay. 0.4772. So that part is 0.4772. How about from 0 to 2.5? So we need to find 2.5. 2.5. And then 0, 0. So 0.4938. 0.4938. That's it. So those are the areas. And then what we need to do, we add. So to get the area of interest, we need to add 0.4772 to 0.4938. And the area that we need is 97.10%. Or the area is 0.9710 and the probability is 97.10. Did you get that? Now let me give you another example. So this is another example. Find the probability that our z is more than or equal to negative 2.5. So in shade or in sketching the graph, what will be shaded? First, where do we find negative 2.5? Lower or upper? Distribution, lower because it's negative. And then what do we need to shade? Everything to the right or everything to the left? Right, because it tells you, no, to shade the values that are greater than negative 2.5. So the technique is it's pointing to the right, so you need to shade everything to the right. The problem we have here is that the table can only give us the area from 0 to 2.5. A while ago, we already had that, and that is 0.4938, right? 0.4938. What about this area? What can we do with this area? Notice that it covered half of the distribution. And remember that half of the distribution has an area 0.5. So, we need to add 0.5, giving us 0.9938. I hope that one is also clear, no? Now, let me give you another example, a different one. Here we have z is in between a positive and another positive. Sorry, a positive z and another positive. A while ago, we have negative and positive. Now we have z, which are both positive. So this is also the same case when you are finding the probability of getting z in between two negative z's. So you will also use the same technique, ha? So what are we going to do if we have this case? Again, the first one is to shade the required region. So 0.5 is seen on the upper distribution, while 2.5 is also seen on the upper distribution, and we need to shade the region between them. The problem is we do not have this area from the table. Recall that the table only gives us the area from 0 to 2.5 and from 0 to 0.5. Right? But this is the area that we need. So what are we going to do then? You get first the area from 0 to 2.5. However, that area includes this hollow part, which we do not need, right? What do we need to do next? You find first the area from 0 to 2.5 and then find the area from 0 to 0.5 which we do not need. So, this is 0.4938, right? There's a part of it that we do not need. So, what are we going to do with that? And that part, if you may notice, is the area from 0 to 0.5. So, let's look for the area from 0 to 0.5. 0.5. Ayan, 0.5. 0, 0. 0.500. So, that is 0.1915. So, that is 0.1915. So, these areas, this area has, ayan, measurement of 0.1915. This region has an area 0.1915. So, anong gagawin natin? What are we going to do with that? We subtract. We subtract these two areas to get the required area. So, the area that we need, ayan, is simply 30.23 or 30.23% is the probability that you will be getting z from 0.5 to 2.5. Clear? So, again, that is the thing that you have to do if you are also finding the probability that z is in between two negative values. Hope that is clear. Well, let me give you another example. So, a while ago, we covered half of the distribution, so we added 0.5 as the area of half of the distribution. The problem here now is we are going to get the area or the probability from z, our z is greater than or equal to a positive value. So if we shade the required region, what are you going to shade again? Everything to the right or everything to the left? Right. Again, that's the technique, no? It points out to the right, so you shade everything to the right. But the problem again is, this is not the area that the table will give us. The table will only give us from 0 to 0.5. And a while ago, we had that. That is 0.1915. 1915. And this is not the area that we need, but the other one. So what do we need to do? Recall that half of the distribution has an area 0.5. So from 0.5, we subtract 0.1915. Did you get that? So we'll have 30.85%. Question? None. You can actually do this, or you can always verify your answers using an online calculator. So you may use this link if you have connection at home. So I would like you to get the answers on worksheet. So I'll be asking you to answer worksheet 6B. So numbers 2 to 6. So that would be your next task. Numbers 2 to 6. Or you can always check your answer, no, using this calculator if you still have connection, internet connection. I would also like to continue to finding the z-scores given the area. So a while ago, we had the z-scores and then you have to give the area. So this time, it's different. You have to find the z-scores given the area. So it is the area that is given and you have to find the corresponding z-scores. So let me continue, no? Finding z given the areas under the normal curve. I hope that this activity will help you understand how to find the z's given the area. So here, class, you will begin with the areas and then you have to, so recall the table. You have to begin with the areas, looking for the areas, and then you have to find the corresponding z. A while ago, we are given the z's, and then you need to find the area. Today, you will be given the area and then we have to find the corresponding z. Is that clear? Let me go back to this guided practice wherein you have to match the graphs to their corresponding z-scores. Let's work first on the graphs. On number 1, the area to the right of z is 0.3583. So what area do you expect is shaded? Is it the right tail or the left tail? Oh, the right tail because area to the right. So among the graphs, which do you think is the most appropriate graph? Oh, the graph that satisfies the condition in number 1. It's either you have graph A or graph D because the shaded regions are to the right. The next thing that you have to consider is look at the area, 0.3583. So which between the two will satisfy that? Question, point of reflection, is 0.3583 more than half of the distribution? No, because half of the distribution has an area 0.5. So, A does not satisfy the conditions in number 1. Right? Because obviously, the shaded area is more than 0.5. So, the most appropriate graph is D. Did you get that? For number 2, this is very hard. No, because this is somewhat similar to number 1. But this time, the condition is to the left. So, what tail are you expecting to be Shaded. Is it the left or the right? Oh, the left. So it's either B or C. B or C. But again, you consider the area 0.3583 is less than 0.5. So it doesn't reach half of the distribution unlike C. So obviously it is letter B. O number 3, the area to the right of Z is 0.8583. So we're left with no choice but to use graph A. Bakit? Because graph A has an area more than 0.5 and the shaded area is to the right. So, our answer here is A. For number 4, this is somewhat similar to number 3. So, obviously, the answer is letter C. But the dilemma here is we have to find Z. So, how do we do that? You look at graph D. Graph D. For graph D, our concern is to find this point. What is this, hindi makita. What is this point or what Z value do we have at this point? So, we have to find this point, the pink one. So, how do we do that? Again, what's the given condition in the problem? The area to the right is 0.3583, right? Question, can we find this area on the table? No. Why? Because the table will only give us the area from 0 to the point that we do not know. So, what is the table giving us? Or what will the table give us? This point. From 0 to this point. Which we do not need. But, is there any way that we can find this area? Yes. How? By subtracting 0.3583 by from 0.5. So, from 0.5, ayan, I'm writing on the right side. From 0.5, we subtract the given area 0.3583. So, you will get 7. 9 minus 8, 1. 9 minus 5, 4. 4 minus 3 because we borrowed 1, 1. So, this is the same area that you see on our PowerPoint presentation. Now, what do you have to do with 0.1417? On the body of our table, you have to look for 1417. 0.1417. So, it's not in the table. So, we need to get the closest. So, it happens to be 0.1406. 0.1406. And what would be its corresponding Z? 0.36. 0.36. Question, is it positive or negative? Positive, because we have the area at the point, the Z-score on the upper distribution. So, our answer must be 0.36. So, here we have to write 0.36. Is that clear? Clear? Okay, erase ko lang. Now, for number 2, we have to apply the same concept. So, we just have to make it negative 0.36. So, here we write negative 0.36. Now, let's go to graph A. Graph A. Excuse me. So, the given area, number 3, is 0.8583. But the table doesn't give us that area. Again, the table will only give us the area from 0 to Z that we do not know. This one. Z that we do not know. How will we do that? You know for a fact that the area of half of distribution is 0.5. So what you have to do? You subtract 0.5 from 0.8583. And if you do that, you will have 0.3583. O where do we find 0.3583? O you look at the body again, 0.3583, 0.3. So you look for 0.3 agad. 3583. So which is the closest? 0.3577. So that is 1.07. 1.07. Question. Is it positive or negative? Raise natin. Is it going to be positive or negative? Oh, it's going to be negative. Why? Because our z can be found on the left side of the distribution or on the lower distribution. So that is going to be negative 1.07. So we write here negative 1.07. For number 4, that is the same as number 3. So we just have to make it positive 1.07. I hope that one is clear. Or if you need more examples, then I have here more examples. So for another example, find the area to the right of z, which is 0.3085. Oh, in this example, you are not given anymore the graph. You will be the one to sketch the graph. So again, you need two steps in answering questions like this. So the first one is you shade again the required region or the given area from the distribution. So since it's given in the problem that z is on the right of the mean, then z is going to be positive. And what do you have to shade? Right or left side? All right. So in the problem it says right. So you begin shading from the right tail. Question. Look at the area. Will this cover half of the distribution or not? Not. So you will end up at this point. So maybe at this point. So you will have ayan, area from the right which does not cover more than half of the distribution. This doesn't reach 0.5. So you do not expect to cross over the mean to the right. To the left rather. Did you get that? Oh, what is this area? The given area is 0.3085, which is not given on the table. What is given on the table? The area from this one to this point, from 0 to this point. And what is this area that we have to find? Or we have to look for at the table. Can we get this? Yes, you can still get this area, this unknown area. By how? By subtracting 0.3085 from half, or from the area of half of the distribution, and that is 0.5. So if you do that, you subtract, you will get 0.1915. And what z value has an area of 0.1915? So you look at 0.1, it's here, 0.1915. And what's the corresponding z? So notice we're doing it the other way. While ago, we're given 0.5 and we need to get the area 0.1915. This time, we are given 0.1915 and we need to get the z-score 0.50. 0.50. Did you see that? 0.50. So, positive or negative? Positive. Because it's in the upper distribution. Oh, I hope that one is clear. If you need another example, this one is worksheet 60 number 1. Oh, you're very lucky. Why? Because we read first. The area from z is 0 to positive z is already given. So if we do the first step, shade the given area. So from 0 to z, that is already 0.3078. Is this area given on the table? So, should we do something else or not? Oh, we have to find the area as is. Why? Because from the shaded region, it's already from 0 to the z that we do not know. So, all you need to do is to find 4.3 0.3, nasaan na yun? 0, balik tayo. 0.3078. Oh, we have the exact value. 0.3078. So, what is its z-score? 0.87. 0.87. Positive or negative? Positive. Why? Because it's already indicated in the problem. And obviously, our z is found on the upper distribution. So, it must be positive. I have here another example if you want to. Ayan. Find z there to the right of z is 0.7612. Question. What are you going to say? Or where do you start shading? From the right tail or left tail? Right, because it's in the problem. Question. Look at the area, no? 0.7612. Will it cover up of the distribution or not? Yes, it will. So you expect your z to be on the lower distribution. So you see, what do you expect about your z? It must be negative. However, again, you cannot find the entire area from the table. So you should do something else. And how would you do that? You subtract 0.5 from 0.7612. And that's the area that you have to look for. So what area are you going to look for in the table? That is 0.2612. 0.2612. So the closest is 0.2611. 0.2611. So what's the z-score? 0.71. 0.71. Okay. Is it going to be positive or negative? Negative. Because it's in the lower distribution. Okay, I hope that one is clear. So I'll be giving you another task to do for this week. And that is worksheet 6C. Numbers 2 to 5. Numbers 2 to 5. I hope that you understand our lesson for this week. I'm working from home class, and I pray that you are all safe. And thank you for cooperating in these trying times of ours. I will appreciate if you also help yourselves continuously learn from our statistics class. Bye for now. See you. Sabi nga ng isang government official sa ibang bansa, we have to stay separated for today so that we can still hug each other tomorrow. Stay safe, everyone. Thank you.